Hello, everyone, and welcome to Precision Roll Grinders webinar on maximizing your nonwoven quality and productivity through precision roll grinding and servicing that brings significant results. We appreciate you being with us today. We hope that you all continue to be safe amid the continuing COVID-19 issues that we all work through. My name is Doug Thompson with Precision Roll Grinders, and we'll be working through this webinar together. A couple of points. Right now, everybody is muted just to help us control background noise. But at the end of the webinar, we'll open it up for questions. You'll be able to unmute your microphone and ask a question in person if you'd like. You're also welcome to use the chat function at any time to go ahead and ask a question. So we'll go ahead and get started. Maximizing quality nonwoven production. And we would just ask if any of these questions have ever surfaced in your facilities. Have you ever had to slow down your line to achieve tests, to achieve bond? Are you removing rolls earlier than you anticipate due to performance? Do you have consistent bond issues, or is consistent bond an issue, either in the machine direction or in the cross direction of your machine? Do you need to change material flow to maintain strength? And do you see inconsistent heat transfer? These are questions that we see commonly working with our partners in nonwovens industry. And today we're going to focus primarily on calendar roll care and maintenance in optimizing thermal point bonding and thermal bonding roll performance. We realize that the scope of roll care, roll maintenance, precision roll grinding is broader than that. And we would be happy to customize a webinar for any of our partners or any of our potential partners out there, either one-on-one or for a group at your facility or at your corporation. Just let us know and we can speak to all the roll needs that you have. The typical roll types in nonwoven calendaring are engraved rolls, smooth steel calendar rolls, nylon calendar rolls, oil heated anvil rolls, hot S rolls, TOKUDEN electrically heated rolls. We have experience with all of these and have history on how to optimize your performance in each of these cases with each of these types of rolls. So what are the critical roll services around these rolls and around your process? We start with grinding. Grinding on the engraved roll pin condition and geometry, on roll crowns, on roll profile, total indicated runout and roundness, concentricity we could add to that as well. The entire geometry around that roll and its pin condition on the engraved side. Internal cleaning of oil heated rolls. Maintaining heat transfer is critical in nonwoven production. Rebuilding those oil heated rolls as required and doing it properly to get the longest life you can and the most consistent heat transfer you can over time is really important. Rebuilding hot S rolls and EAGLEBURGMANN seals. Rebuilding and testing of electrical TOKUDEN rolls. Pin repair on engraved rolls. Bearing and housing disassembly, inspection and assembly is also really critical to get the life and the performance out of the rolls. And balancing, of course. Journal repairs and then any other repairs. With respect to engraved rolls, pin condition and roll geometry is critical for both bond and roll life. We partner with you to really keep track of that, really take a look at it when the engraved rolls are serviced. Smooth calendar rolls, anvil rolls, again, roll geometry, heat transfer are critical for bond and roll life. Same with hot S rolls. With TOKUDEN rolls, the electrical testing is critical. We've got quite a history of doing that and doing it well as roll rebuilds and repairs, and of course nylon roll grinding to maintain geometry, as we mentioned in the other rolls. 3D and hot grinding roll services, absolutely necessary to maintain roll shape for optimal performance over time. And as those rolls heat and deflect and the metallurgy over the curve of heat takes effect, we partner with folks to make sure that that's done properly. Internal roll services, hot oil, hot water, hydraulics, all need to be in proper service. And then again, all other roll services, extended life of roll covers, journal and bearing repair, and new rolls. So when it comes to roll performances, we start with grinding tolerance matters. You can see the graph on the lower left-hand side. The profile of the two rolls creating the nip is critical. Light contact areas requires more pressure to achieve bonding. Heavy impact areas wear the pins, damages pins, and may lead to burn through. So there's a very specific geometry, as you all know, to get proper bond in your non-woven calendars. We're very aware of that. We're very sensitive to that. So the roundness in machine direction, the shape in the cross direction all becomes critical. And that's a real world example of what can happen when the shape is not correct on rolls, where you end up with areas of light contact and areas of heavy impact. So you get that inconsistent bonding across your web. So at the end of the day, literally tons of performance in your facility and off of your machines depends on tens of thousandths of an inch. So all your rolls, not just in a calendar, the shape, the total indicated run out, and the roundness are critical. Uniform nip pressure is absolutely necessary for high performance. So the entire shape and the entire roundness, entire concentricity and run out of that roll needs to be maintained and needs to be maintained well. The roundness matters. Critical rolls should be anywhere from 1/10,000th of an inch to 2/10,000ths of an inch. Most grinding facilities can only achieve about 4/10,000ths all the way up to 2/1000ths or 20/10,000ths. You can see below actual graphs of what rolls look like before a proper grind and then after a proper grind. We talked about performance in the calendar with respect to bond, but the other performance that you need is life out of those rolls. So this is actual data that has come from one of our partners, or actually in a number of our partners. We've evaluated this over time in a number of cases and across industries, quite frankly. So the deformation of a roll is a function of the roundness of that roll. It's kind of like the washboard road effect. So the closer to perfectly round you start that roll, the flatter that curve, and it's not linear, the flatter that curve is on the front end. So if you start a roll that's got roundness tolerance of 2/10,000ths versus 8/10,000ths, as you can see, it takes almost a year for that roll that began at 2/10,000ths to wear into where you may start with a roll received that is at 8/10,000ths. So rolls that start closer to perfectly round run longer. And we've been able to prove this across industries, not only in nonwovens, but in paper manufacture, rubber manufacture, and others. Again, just to emphasize, uniform nip pressure matters. The footprint as that web goes through the calendar. Thermal point bonding and uniform nip pressure impacts both machine direction and cross direction bonding, as we've mentioned. The pin and roll wear over time. Again, if you've got light contact areas, quite often you're having to compensate with pressure. Calendar speed and vibration, the roundness, the concentricity, the shape all play into calendar speed and vibration. Burn through in those areas of heavy impact. Surface abrasions, tensile strength, damaged fiber, debonding, and then of course the density and softness that you're trying to control in your product as well. So how does grinding engraved rolls well improve performance and extend roll life? With newly engraved rolls, tolerance is better than OEM. translates to improved performance. It all ties together. It goes back to the roundness that we were just speaking of. The closer you can get to perfectly round, the shape, and how all that acts together in your bonding area in the calendar. And then subsequent roll grinds. Minimal diameter reduction to extend roll life and number of grinds. Critically important on both anvil rolls and certainly engraved rolls. Reestablishing that pin surface and that pin geometry so that you're getting the proper performance out of that calendar. Heat matters. So we've talked about roundness, we've talked about shape, we talked about uniform nip pressure that comes from that, and then we need to talk about heat. Rolls need to run at designed operating temperatures, as you all know. Bonding requires that uniform heat transfer across the web, and as the calendar turns, roll tolerances require uniform heat transfer. Again, at operating temperature, that roll's different than it is at ambient temperature, which is seen on the right-hand side there. So all those factors come into play. And then are you measuring roll surface temperature? Are you seeing those variations in your surface? And where are they coming from? These are the questions that we partner with our customers to investigate and to answer, and quite honestly to solve. So again, along the lines of heat being important, heat matters. The periodic cleaning of oil heated rolls. There are different heated roll designs for both engraved, smooth, and anvil rolls, or I should say for all three. Peripheral holes, there's can design, there's spiral can design. All rolls must be cleaned periodically to ensure uniform heat transfer. Not only do you need the service to provide the right geometry, but you need the service to provide the best heat transfer. This is an example of removing a can from the shell. The can design has spiral baffles and is contaminated with sludge. So obviously the heat transfer is not going to be optimal. So the periodic cleaning of these oil heated rolls, again, it becomes very critical. You can see what it may look like before cleaning and what it does look like after cleaning. Along the lines of heat, proper hot S roll maintenance matters, obviously. Hot S roll inspection and rebuilds for both basic designs with the internal bearing design and external bearing design. Those rolls need to be open and inspected. If there's roll failure, that needs to be investigated, and we need to partner to do that troubleshooting. The roll needs to be rebuilt so that the components that drive the performance of that roll are true over time. The roll needs to be tested. And again, back to shape and roundness, the roll needs to be ground. Experience with the EAGLEBURGMANN seals. Again, two basic designs, bellows and spring pusher. Working with EAGLEBURGMANN to inspect and rebuild seals. This saves time, it saves money, and it's something that, again, we partner with our customers in the nonwovens industry to do. This is an example of a hot S250 external bearing design for higher temperatures. Differs from the S170 design that has internal bearings similar to a normal hydraulic swim roll. The pedestal drive unit there, and the precision that needs to go into the maintenance and the seals of these rolls is important. And precision is a way of life, right? It's the grinding, it's the shape, it's the cleaning of the rolls, and it's also the maintenance of the rolls. So a precision culture is really necessary to maintain these rolls in optimal working condition to help you optimize your line. And this is just an example of all the things. There's 6 things there on the right-hand side that all need to be right. The filler tape, the support rail, spring tape, axial seal, bow tape, Teflon insert. These are things that you need your service provider for rolls to be familiar with, to know how to see, to know how to troubleshoot, and to know how to maintain properly. Again, rebuilding EAGLEBURGMANN seals. Just an example of the bellow side element, the silicon carbide rotating element, damage that occurs in the interface between the two parts. These things, again, all need to be inspected, all need to be right when your roll goes back together for optimum performance. And continuing along the lines of heat, proper TOKUDEN roll maintenance and TOKUDEN roll performance. These are obviously electrically heated rolls. This is just an overview of all the components to make the point that, again, similar to what we saw in the previous two slides, and all the components that need to be right, all these components need to be right as well. So experienced shops in TOKUDEN roll maintenance and how to make sure that those services are provided to you. State-of-the-art testing equipment and processes, and again, experience some proper disassembly and assembly of these rolls. The basic repair operations around the TOKUDEN rolls, obviously bearings and housings. It all starts there from the journal all the way up through the concentricity, roundness, and shape of the roll. The electrical testing that we talked about, that takes specific equipment and specific skill set. Internal bearing replacement, the removal and installation of the rotary transformer, rebuilding the rotary transformer, replacing the K thermocouples, removing and installing the coil. We point all these out not to be redundant, because we know you understand this, but to again re-emphasize the point that precision happens not only in the grinding, precision happens in the roll maintenance as well. So other roll services that are critical for your roll performance: bearings and housings, disassembly, inspection and assembly, pin repair, balancing. The roll has to be balanced when it goes back into your machine. Journal and bearing seat repairs, and then hot grinding and 3D grinding. So 3D and hot grinding, the ability to map the surface and to map the roll geometry at operating temperature. We also have the ability to hot grind at operating temperature, but the 3D mapping allows us to understand how that roll is going to act at operating temperature, and subsequently downstream maintain it at ambient temperature to make sure it operates properly at operating temperature. So really, your roll service needs to be a one-stop shop. All internal roll work that we talked about, the heat passages, hydraulics, TOKUDEN electronics, the mechanical and machining, journal repairs and replacements, bearing installation, removal and installation, I should say, expertise in cover technology, rubber covers, chrome, ceramic, tungsten carbide, all that comes into play. And at the end of the day, the promise is to provide real documented value through Precision Roll Grinders experience and Precision Roll Grinders expertise. And by documented, we mean exactly that. The graphic on the right-hand side is there for a reason. It starts with data. We partner with our customers to collect the data that's important to them. It could be bond, it could be efficiency, breaks, whatever is on your Pareto chart that you're working on. And then working together through design of experiment and through linking your roll performance and your roll services to actual performance in your operation and on your machines. So the idea is to take something that is got more variation than it should, partner with you to reduce that variation, allow you to shift it for your economic benefit and through efficiency, strength of product, whatever that might be, and ultimately drive it to a predictive equation that we can use with each of our partners that predicts that value every time that roll service occurs. And again, everything plays into it. The roll grinding, the roll maintenance, the roll life, all plays into it to drive to a real economic value for our partners over time. So any troubleshooting on rotational equipment in this time of virtual communication with our customers, we encourage you to reach out with anything, data, video, pictures. We realize that we still can't be on site in many cases, but that doesn't prevent us from providing the virtual services with respect to this kind of data collection and analysis and troubleshooting. Joint design of experiment to reduce variation. This is we put Six Sigma rigor to this. We have an application engineering group now that's relatively new to precision roll grinders, and they do a fantastic job of, again, partnering with our customers to go out there and find this variation together and work through design of experiment to reduce this variation so that you see the economic gain that you need. So again, we're adjusting to our new virtual partnership. We hope that it doesn't last too much longer, but we just wanted to share with you what we felt were the critical pieces to the roll services and the roll performance that you need in your nonwovens facilities to optimize and maximize your productivity and performance. So with that, let me open it up for any questions that folks may have. And okay, everybody's got audio control now. So if you do have a question, please feel free to unmute your microphone and chime in. There's a chat function there as well if you want to ask a question that way. You're more than welcome to do that. We wanted to be sensitive to your time. It's 2:22, and we'll try to wrap up by 2:30, which is what the original schedule was. Okay, we've got a couple questions that have come in, and I may ask Peter to chime in on these. The first question is, how many grinds do you generally obtain on an engraved roll?
Hi, Doug. This is Peter. Would you like me to jump in and respond to that question?
Yeah, if you would, Peter, thank you.
Well, it can be quite a range depending on the operational situation at the customer, but we've seen 0 where the roll is damaged up to 6 grinds. And what we try to do is position it so that we're doing everything possible to get the maximum number of grinds. And we start out with the initial pin geometry. As you mentioned in the program, that our tolerances are tighter than the OEM. Our most finicky customers have us do the pre and post grind. This ensures the initial pin geometry is the best it can possibly be, and that's starting with the foundation for subsequent grinds. Then the next step is grinding the engraved roll and the roll it's running against, a hot S or an anvil roll, to good geometric tolerances. This ensures that in your operating conditions, you have uniform wear, at least dictated by the rolls. There's other factors in your process, but the rolls are starting at the best point they can. So then when the roll comes out, for whatever reason the operation the customer dictates, it comes back to us, and we're going through a process of setting up the rolls and reestablishing the best possible grinding condition, so we remove as little material from the pins as possible. And we're trying to remove as little as 2 thousandths, and it's typically around 3 thousandths, so that the less material we remove, the more grinds you'll have. And I would say our typical number of grinds is 3 to 4 for the typical nonwovens operation.
Okay, great. Well, while I have you warmed up here, would you mind answering another one? This one is, how often should oil heated rolls be internally cleaned?
That's another good question. And I start out with the baseline that every oil heated roll should run at least 5 years. And a customer should be measuring the temperature of the roll across it periodically. And if you're not maintaining uniform heat temperature for 5 years, when we do the open inspect, that requires then problem solving and a dialogue with the customer. And in most cases, you can develop an assignable cause, correct it, so that you can maintain at least a minimum of 5 years.
Okay, thank you. And we had one more so far. How long should a hot S roll run between rebuilds?
That's another question, good question, and it's a similar answer. I'd like to shoot for 5 years, and if it's not running for 5 years, then you have to do a detailed analysis of the Bergmann seals and the internal sealing system and try to pinpoint the cause of failure and then develop a corrective action. And in some environments at the customer are more challenging than others, and you can't always maintain 5 years, but you should be able to develop a root cause, whether you can correct it or not. A customer might have issues with their oil filtration system where they just can't get clean oil and it's causing wear, for example. But the key is to do the troubleshooting and try to determine why you're not hitting the objective of 5 years and then take corrective action.
Okay, thank you. And we had one other question come in via chat. Does precision roll grinders have support outside of the US? Absolutely. We've got a sales manager in Central and South America, Jefferson Leite, who's located in Brazil. We've done work internationally in the nonwovens business as well as others. We do have support structure and understand international business in Asia, Southeast Asia, Europe, and certainly in South America and Latin America. So if you are part of a corporation that is looking for somebody to be that roll service provider globally, then absolutely. And then another question just came in via chat. You talked about studies. How long do these type of things take? What kind of resources are required from me, the customer? That's a great question. The studies, it depends on what's being studied. As Peter mentioned, if we're studying the length of roll life and maintaining quality of bond or quality of caliper over time, then it could be a year of data after a newly serviced roll is installed. Generally, we can get a pretty good feel statistically within 4 to 6 weeks. We need to make sure that we have data enough prior to the change and after the change to make sure that we've statistically made a difference together. So what we ask of our customers is just access to that data. We understand in many cases that can be sensitive. We're very aware of having those non-disclosure agreements in place with everyone and not sharing that. We would never share that kind of specific information with anybody else. We just share very broad information like we have in this webinar on the importance of certain aspects. So Usually the studies are within a 6-month period of time. Sometimes they will go longer and sometimes they will go shorter, but probably the average study is somewhere around 6 months. We want it to be real and to really drive economic value for our customers. Those are all great questions. We appreciate it from everybody. Okay, are there any other questions at this time? Well, we really appreciate your attendance. We appreciate you getting on and watching this with us. This will be available on our website, and it also will be available on our YouTube page. So if you've got coworkers or others that you would like to have view it, we'll have it up very shortly on each of those platforms. Again, thank you for your time. Please feel free to reach out to us directly at any of our facilities as shown here or any of your local account managers. Continue to be safe, and we look forward to working with you soon. Thank you.